Think I just had spring break or something. All right. Welcome to spring term. Woo! We're going to start off with chapter one. There's really no math today, or almost no math today. So you don't need your fancy calculator. The calculator that I'm going to use in class looks like this. It's a TI 84. I believe that some of my videos and things also talk about TI 83. I'm going to try to help you with that a little bit as well. If you have something different, Google might become your best friend. But you can rent these from the library, RCC library. I think it's $20 for the term. Otherwise, they're kind of expensive. I use an emulator that I pay for. Now, the emulator, you can't use it on a test, but if you wanted to use it for homework, you can. There's a kind of a convoluted way to get to a free TI 84 emulator on the computer, where you would have it on your screen. I have a way to get there. I'd have to walk you through it. If you want the on-screen calculator, send me an email or a message and I will give you instructions on how to get there. It's some weird backwards way that I found to get there. And basically some college has it on their site for their placement test, and you have to get to their placement test screen, but you don't actually have to take the test, you just get the calculator. So if you want the on-screen emulator, just send me a message and I will give you instructions on how to get there. Otherwise, you can check out the calculator from the library. You will need to have an actual calculator for the test. You can't use your phone or one on the screen. Okay, so we're going to start on chapter one. It's a lot of vocabulary. This is the most boring class of the entire term because it is mostly vocabulary. Stats is like a whole nother language. It's very different than other maths. So there's a ton of vocabulary. And so I'm sorry in advance for this being kind of boring, but it gets better. It gets more exciting. It gets more fun. We'll have a good time. I promise that. Well, I don't like to promise things, but you're going to have a good time. All right. So we're going to define statistical thinking. We're going to talk about the process of statistics. We're going to talk about quantitative and qualitative variables, discrete and continuous. And we're going to talk about levels of measurement, and I'm going to tell you how I best remember things. Then we're going to start to organize some data in tables. We're going to do most of 2.1, but not finish 2.1. But after tonight, you'll be able to do the chapter one homework, which is required for your for attendance. And we're also going to construct bar graphs today. So that's today, and we will do the lab on Thursday. I'll walk you through that, and I will talk about what kind of data you need for the lab at the end of this class. Okay. Maybe my iPad is not switching pages for me right now. Oh, that's why. Hold on a second. No, I want it to be. Why isn't it letting me do this? There we go. Okay. So first, statistics it's a science. It's a type of science where you collect, you organize, you summarize your data, you analyze it. You're looking for a conclusion. You start off with a question, and then you collect the data you need and you analyze it in order to ask that question. So I am not going to require you to come back and tell me what this is. This is just kind of your background. So data or data, I use both of them interchangeably. Who knows which way is really the right way to say it, but I'm going to say it both ways all the time. So it is the numbers that we collect or the information that we collect. It is a fact or a proposition, characteristic, something like that that we use to make our decisions and draw our conclusions. Could be numerical or it could be non-numerical. So either way, it describes a characteristic of an individual. So we're going to try to use the data to prove a point, to determine whether or not we're using the data correctly. And we're going to all sorts of real cool stuff. Trust me, it's really cool stuff. So this is vocabulary that you're going to need to remember. In your chapter one homework, it's going to ask you, you're going to have to tell whether something is a population, a sample, or an individual. So the population is the entire group that we're studying. So it is the whole group. So we're not going to necessarily poll the whole group and talk to everyone in the group, but it is the one that we're making predictions about. It's the thing that we're talking about. So if I was doing a study about RCC students and determining whether or not, or whether there was a correlation between how much they studied and what grade they got, then RCC students would be my population. So even though I'm not going to talk to all the students, that's who I'm studying. I'm studying RCC students. The sample would be the actual people that I talk to. So it is a subset of that population. So my sample would be like if I'm selecting 50 RCC students and asking them how much they study and what their grades are, those 50 students, those are my sample. Those are the people that I'm studying. So an individual would be one RCC student. So one person, the one person whose data I have, or one of those 50 or one of the whole population, that is an individual. If you have questions, make sure you stop me or you just post in the chat. I will glance over frequently and try to answer your questions if you pop it in the chat, or just pop in, because I can't see hands raised and things like that. So just unmute and speak if you have a question. All right. So you're walking down the street and you notice that a person walking in front of you drops $100 and no one notices except for you. You could keep the money without anyone knowing that you kept it. And I'm asking whether you'd keep it or not. When I teach this in person, generally I put a Post-it note at everybody's station and they anonymously write whether or not they would keep the money. Then I collect them and I determine whether or not they would keep it. So when I teach stats in high school, I usually have more students saying they're going to keep it than when I teach stats at the college. Most adults would not keep it. And I think it's probably because the adults are thinking, well, if I dropped $100, that would hurt. I would want to get it back. So I'm going to just hypothesize. I'm going to just guess. I'm going to make up a number. So let's pretend that I'm going to pretend that there are 30 students. And let's pretend that 28 out of the 30 students would return the money to the owner. Oh, my grandson did some weird things to my calculator. So that would be 83%. It's 83.3. That's not right. I mathed wrong. I mathed so wrong. Oops, there we go. That is 93%. Okay, so 93% of our class would return the money. We're pretending 28 out of 30 students return the money. So since this is a sample of all RCC students. So this 30 people that I polled is a sample of all RCC students. Therefore, it is statistic. A statistic refers to a summary of a sample. Now, at the end, I'm going to give you like an overview of all of it. I'm going to summarize it, but statistic refers to a sample. One easy way to remember that is thinking they both start with S. A statistic is numbers that refer to a sample. So descriptive statistics are when I use those, all I'm doing is giving you those numbers. I haven't actually drawn any conclusions by them. I just putting the numbers down either just like I did here. I might put it into a graph, or I might put it in a table, but I haven't used it to draw any conclusions. I haven't applied it to the entire population. All I did was just say 93% of our class would return the money to the owner. So I haven't really done anything with the numbers. I just kind of stated what people said. So that's descriptive statistics, but a statistic just refers to a sample. Questions? All right. So once again, did I say 28? Yeah, I'm going with 28 out of 30. I go in 93%. So now if I've decided to apply this to the entire college, I'm applying this to all RCC students, I would be using inferential statistics. So what this does is it takes the result of my sample and it extends it to the whole population. So when we do this, you have to give a margin of error. You've probably seen this in like presidential polls and things like that. We need a margin of error. Now, the margin of error is not going to come until about week 7 or 8, I think, but I'm just going to kind of apply it here. So I might have a 3% margin of error, and so I can say that of all RCC students, I can say with 95% accuracy that between 90 and 96 of all RCC students would return the money. So here I am applying it to the entire population. Now, this is a number I just grabbed out of the air. I just decided that the margin of error was 3%. There's a whole lot more math that goes into that, but for these purposes, this is just an example, so it's no big deal. So I'm saying that with a 95% certainty, I could say that 90 to 96% of all the RCC students would return the money. And we're just applying it to the entire population here. That's inferential statistics. I'm inferring something based on my sample. All right. So this right here, so suppose the percentage of all students on the campus who have a job is 84.9%. So if I take the entire campus and everybody on campus, 84.9%. So if I took a sample of 250 students, that sample, 86.4% of that sample have jobs. That's a statistic. So parameters refer to population. You will be asked this in your assignment. Statistics refer to samples. I love that they start with the same letter of what you're referring to. So when you're doing your homework on chapter 1, be really careful when reading it to see if they're talking about a sample. So they don't always say that they're referring to a population, but they most of the time will say something like, we polled 50 students, or, we took a sample of 25 students, or something like that. Usually, if it's a sample, it's pretty clear. It's usually less clear if it's a population, because they don't always say, of all of the RCC students. So they're usually a lot more clear when it's a sample. But this is the breakdown right here. Statistics refer to samples, and parameters refer to population. So we use inferential statistics to estimate parameters. We use statistics to estimate parameter. So using the sample to estimate the population, because a lot of this refers to the whole US, and I really doubt that I can poll every single person in the whole US. Any questions so far before we move on? All right, moving on then. Okay, I am not going to ask you to tell me the process of statistics. I just kind of want to let you know how we do this. This is going to look a lot like, and statistics is a lot like the scientific method. I'm not going to use all the same words, but it does look a lot, and it follows it a lot, because stats is kind of a science-ish. So the first thing that you want to do is you want to identify your research objective. So the first thing you want to know is, what do I want to know? What am I looking for? Which population am I trying to study? What question am I trying to answer? So you obviously need to know what you want to know before you start collecting data or doing anything else. What am I trying to show? Then collect your data. So figure out what you want to know, and then collect whatever data that you need to collect in order to see, to learn that. So you're going to usually look at a sample. There's a lot of math that we're going to use later on to determine how big of a sample you need. You also need to be really careful with how you sample your data. Using a random sample is the best thing. This little box right here talks about convenient samples. So one example I like to use is, if I ask the question, is President Trump doing a good job? I'm going to get very different poll results if I put that poll on MSNBC than I am if I put that poll on Fox News. So you need to be really careful. Convenient samples are whoever happens to be in the area is going to answer it. If I'm standing outside of Walmart and I ask, is Walmart have competitive pricing? I'm going to get very different answers than if I go stand in front of Winco and ask, does does Walmart have competitive pricing? I'm going to get very different answers. Convenience samples are not the most accurate. So you need to be really careful with how you're sampling your data. Now, in this class, because it's a lot more difficult for us to have nice random samples and things like that, I'm not going to care so much if your samples are random samples or convenient samples or whatever. I just want you to state how you got your data. It doesn't have to be nice and pretty and perfect and, simple random samples and all that. So after you get your data, then you need to describe your data. So you're going to put it into graphs, you're going to put it in a table. You need to figure out what kind of math do I need to do on this in order to answer my questions. So you're just describing it. So it's just going to be descriptive statistics at that point. And then number 4, now is when you're going to math it out. Now is when you're going to apply all your techniques. You're going to do all your analysis, do all the fun math stuff that you get to learn this term. Yes, it's fun. Trust me. So you get to do all that fun math stuff, and that way you can you know, figure out how to answer your question. That's where you answer your question. And you're going to want to write a nice conclusion and all of that stuff. So that's number 4. So this is our process. And you're going to be doing some of this. So especially in your final project, which very beginning of the term, I'm already excited about final projects. They're my favorite. But don't worry, don't even think about those. Don't worry about those yet. All right, questions so far? Can we move on? All right. So here's an example. So many studies evaluate batterer treatment programs. There are a few experiments designed to compare the programs to non-therapeutic treatments. So sometimes a lot of times for people who battered their domestic partner, they just have them do community service. So this research, what they did was they took 376 male criminal court defendants who were accused of assaulting their intimate female partners. Half of them were put into a control group and half of them were put into a treatment group. So those in a treatment group were in a 40-hour batterer treatment program, while the other half did 40 hours of community service. After 6 months, 21% of the males in the control group further battered their intimate female partners, while only 10% in the treatment group had further battering incidents. The researchers concluded that the treatment was effective in reducing repeat battering offenses. Man, that's hard to say. All right. So step 1, identifying the research objective. Our research objective here was to determine whether a treatment program was going to make people less likely to batter again compared to community service. So they wanted to know if this treatment program is going to be effective. That's what their research objective was. Next, they needed to collect their information. So what they did was they put their 2 groups into the 2 different things. One was the control group and the control group in the community service. The other one was the batterer treatment program. So see, all they did was just describe what they did. And they looked after the program was over, they looked at the percentage of how many battered again. Next, this is where they're going to start organizing their information. They're going to start describing their data, doing all of that stuff. So after 6 months, 21% of the males in the control group had further battering incidents, while 10% in the treatment group. So this is just my descriptive statistics. I've not made any inference yet. That's next. This is the final conclusion. We extend the results of the 376 males in the study to all males who batter their intimate female partners. So males who batter their female partners and participate in a batter treatment program are less likely to batter again. So there we go. That was a lot. It's a lot of words. So that is the step, and there's your example. So you're not going to be, it kind of just gives you an idea. One thing I like about giving this information to you is that when you start reading articles and seeing the way that people do their studies, you're going to start noticing things. You're going to start noticing that people miss steps or they start stacking the deck and taking and like they will already collect data that leans more in their direction. Like for example, asking a question if they want it to look like people have a high favorability of the president, they're going to ask it on Fox News. If they want people to look like they really think Walmart has great prices, they're going to ask questions outside of Walmart. So it depends on what they're trying to do. A lot of people do try to stack the deck in their favor. Happens a lot. Okay. Sorry for more vocabulary, but it is what it is. This is just the heavy vocabulary day. We get to do the fun stuff later. Gets more and more fun as we go. I know I'm the one who majored in math, so you can't really take my word on things being fun. I'm the weirdo that chose to major in math. So a variable is just exactly that. It is variables vary. It's going to be the characteristics, all the different outcomes of the characteristics of an individual. So a variable is just a variable. Sometimes it's the letter X. It is what it is. So qualitative or categorical. So this is you're going to have questions about these on whether something is qualitative or quantitative. I usually say categorical. I say categorical more than I say qualitative. Qualitative is what the book says, and I don't know what my open math says. I can't remember. And I just noticed that categorical spelled wrong. What the heck is wrong with me? Categorical. There we go. So categorical variables, they're usually words. So like hair color, gender, things like that. It's either words or numbers that you don't do math with. So it's going to be some attribute. So it could be the color of their hair. It could be color of houses, color of cars going by. It could be um, like breed of cat. It could be something like that. It's usually something that is a word. It could be numbers you don't do math with, like hair color or like zip code. You don't do math with zip codes or phone numbers or birth dates. We generally don't do, unless you're talking about years people are born and how old they are, maybe, but it's would be numbers you don't do math with. So it could be numbers on the houses, something like that, or numbers on license plates or something, but it's not going to be numbers you do math with. Quantitative data, think quantity. These are the numbers you do math with. These are usually things that are measured or things that can be counted. So these are numbers you do math with. Temperature, number of days students have studied, weight, height, things like that. So categorical or qualitative is mostly words or numbers you don't do math with. Quantitative is numbers you can do math with, things that are measurements and things like that. Questions? Alrighty. So let's look at some examples. So this researcher, Elizabeth Kavavic, she studied the effects of eating habits on adults in their mid-30s. And so we're going to classify each of these variables, whether they're qualitative or quantitative. I'm going to use the word categorical because I just like that better. So nationality. Nationality is categorical because it is a word. It's words. It is, I'm German, Irish, English. It's words. So you can't do math with it. Number of children. Number of children is something I can do math with. Therefore, it is qualitative. Household income in the previous year, once again, I can do math with it. And trust me, I do a lot of math with income. So level of education. Sometimes it's numbers, but generally it's words, and we don't usually do math with it. It's like I have a master's degree, therefore I can't do math with a master's degree. I mean, I guess I can because part of it's in math. Daily intake of whole grains measured in grams per day. Once again, numbers you can do math with. So quantitative. What the heck, man?
Yeah, above there, I'm confused because isn't categorical and qualitative the same
Yeah,
thing?
I just noticed that I wrote the wrong word. Sometimes when I'm talking and writing at the same time,
Yeah, I can't drive and talk either, so you're forgiven.
sometimes I'm writing and talking at the same time, and my hand has a mind of its own. Quantitative. There we go. Yeah, sorry about that. Thank you.
Same thing with the number of children too.
Yes. Yeah.
Yes.
Yeah, I said the right thing. Okay, let me just duplicate this. I said the right thing. I just didn't write the right thing. There you go. Sorry about that. Thank you. And what would I do? And you see, normally people don't correct me the first day of class. I appreciate that. Please keep it up. If you guys catch math errors, absolutely correct me because I believe everybody has 5,000 bad math problems in their body and mind, and you got to get all 5,000 of them out. I'm not out yet. And so they still keep coming out. All right. So now we're going to take our quantitative variables and we're going to break them into two more categories. Qualitative is still going to sit over in its little spot all by itself. It doesn't get to get broken up into categories. But the quantitative variables, they're going to get broken up into discrete and continuous. So if you're thinking back, if you took math, I think math 60 is where you learn about discrete and continuous. If you took math 60, or maybe you took algebra 1 in high school, um, and it's the same thing. These discrete and continuous mean the same thing. So discrete variables, they're quantitative and they're going to have a finite number of possible values. Generally, it's something that's countable. So number of students in class. I'm not going to have 1.48 students in my class. How many TVs sold last week? I'm not going to sell 13.8 TVs. Number of red marbles in a jar, things like that. So it generally is something countable or something where you can't take on every value in between. If I was to graph a discrete variable, it's going to look like dots on the graph. I have to lift my pencil up between each number because it can't take on every value in between. So discrete, you have to lift your pencil when you graph it. Continuous, continuous can take on every possible value between two values. So it's usually something that's a measurement, something like how much you've grown or a distance or things like that, or a temperature, because it can take on every value in between. I can't drive 30 miles before I've driven 29.5 miles. I have to hit every value in between to hit that 30 miles. It's not going to be 45 degrees until it was all the other degrees leading up. I can hit every single temperature because I don't go straight from 45 degrees to 46 degrees. I have to hit every value in between before I get there. So examples: height of a student in class, time it takes to get to school, distance traveled, weight of a baby at birth. So it's usually something that's been measured most of the time. And so when it comes to money, so money is kind of a tricky thing. So, money, a lot of times we'll call that continuous, even though obviously you're going to go, if you have $1.95, you don't go a dollar 95.3, you jump to $1.96. But in the grand scheme of things, that those pennies are pretty finite, they're pretty small values. So we will usually with money, we'll kind of go continuous, like income, we go continuous. But you just gotta kind of figure out what the situation is there. So let's do the example here with Elizabeth Kavavic again. So number of children we have, children are countable. You don't have 1.48 kids. So this would be discrete. Once again, household income, I told you money, we usually go continuous because I can't earn $1,000 without first earning $999. So, or $999.99. So generally it's a continuous. And letter C was kind of tricky also thinking about it. These aren't the best examples, but number 3 is also kind of tricky, but I'm not going to eat 1 gram at a time. And I can't eat 100 grams without first eating 99 grams. And so we'll call this continuous as well. Continuous. So there we go. Questions on this?
Yeah. What do you do with average numbers? Like if you have something that normally is discrete, but like we have an average of 4.3 children, does that become continuous?
Well, we don't really classify with averages like that.
They
So
just don't go into either category, it's its own thing.
yeah, it's its own thing. I wouldn't even really worry about that. We're usually representing it with like the raw data. So the raw data is before you've done anything to it. And I think that might even be on my next screen. The raw data is before you've cooked it, before you've done any math with it. And so it's just like when you have your pile of data, that's when you can talk about is it continuous or discrete.
Thanks.
You're welcome. That was a great question. I don't think anybody's ever asked me that before, which that's really saying something. Okay, I'm gonna give you a disclaimer here before I hit levels of measurement. So levels of measurement is a topic that many people struggle with. So I'm going to tell you how I remember it. If you printed this off, then it's a really good idea to make the notes on it, or maybe just go back, print it, and go back later about how I remember it, and it might help you. Maybe not. I don't know. Or when you're just writing them down. So the first two levels of measurement are for categorical data. I'm going to write that down right here. They're for categorical data. So nominal level is when order doesn't matter. So that's usually how I think about it. Order doesn't matter. It's just kind of a pile of information and order doesn't matter. Sorry about that. So for example, gender. It doesn't matter whether you say male, female, or female, male when you're doing your data. Handedness, left or right, it doesn't matter which one comes first. Religion, your favorite color, it doesn't matter which order we list them. Order doesn't matter. It's just a pile of data. So with ordinal, order does matter. So grades go either A, B, C, D, F, or they go, up or down, whichever, but they have a specific order. So with ordinal, order matters. When you're talking satisfaction rating, those little things where you're clicking a box, it would go like extremely dissatisfied, neutral, satisfied, extremely satisfied. It's going to have an order to it. Or you talk about like level of education. Level of education, you're going to have elementary school, middle school, high school, maybe community college, or associate's degree, bachelor's degree, master's degree, doctorate. There's a specific order there. So ordinal has a specific order. Nominal order doesn't matter. So those are the categorical ones. These ones are quantitative, and I'm going to write the right word here. So these last two are quantitative. Now, these ones are the ones where people struggle. So with the interval level of measurement, there's a couple of different things here. So this is important right here. A value of 0 doesn't mean the absence of quantity. The first thing I always do when I'm looking at numerical data and I'm trying to determine is it interval or ratio, I ask myself, does a value of 0 mean absence of quantity? Does it mean I don't have anything at all if it's a 0? So this one, 0 does not mean absence of quantity. Also, here's the other one. The math you do with it is usually addition and subtraction. We generally do not use multiplication and division on interval measurement. So, for example, temperature. A value of 0 doesn't mean absence of quantity. If it's 0 degrees, it doesn't mean that I have no temperature. It just means that it's really cold. Calendar years. A year 0 doesn't mean there's no years happening because we go back to before the Common Era. Elevation. An elevation of 0 just means you're at sea level. You can go below sea level in elevation. Think about temperature. I'm not going to say it's twice as hot today as it was yesterday. I would say it's 10 degrees hotter today than it was yesterday. So that's addition. I can add and subtract numbers from it, and I wouldn't say 1970 is twice as many years as 900, and that was a terrible one. Whatever that is, 985. That you don't say that. That is just weird. So we don't generally use multiplication or division for these. But the absence of the zero, this right here, this is your gold. The value of zero doesn't mean absence of quantity. That right there is your gold. So with ratio, a value of zero means absence of quantity. So if you have if it's zero, it means there's nothing there. And generally, we can use multiplication and division. Yes, you can also use addition and subtraction, but I can use multiplication and division here. So money in my pocket. A value of zero does mean absence of quantity. If there's no money in my pocket, there's no money in my pocket. There's nothing there. Height in feet and inches. If you had a zero height, it would mean there's nothing there. Same thing with weight. Time spent watching TV. A value of zero means I didn't watch TV. So your gold right here is the value of zero does mean absence of quantity. And I can say I watched twice as much TV last week as I usually do. That's something where I can use multiplication. I watched a third amount of TV as somebody else did. My cat weighs half as much as her brother. That's multiplication and division right there. She weighs half as much. I divided his weight by two. So that is the math that I can do here. Any questions about these? Because I know these can be a struggle. Okay. See, these weren't supposed to already be on there, but gender would be nominal because it doesn't matter what order it is. Temperature is interval because the zero does not mean absence of value. Number of days a college student studied this week. If you studied 0 hours, you didn't study. Therefore, it's ratio. Zero does mean absence of value. Letter grade earned in stats class. It's ordinal because grades go A, B, C, D, F. It was supposed to be blank and we were supposed to talk about them and write them in, but I messed up. We doing okay so far? Is everybody still alive? Okay. We are in section 2.1. We just finished chapter 1. Good job. If you keep track of that sort of thing, we are moving on. You now have all the information you need to finish the chapter 1 homework. We are not going to we're not going all the way through 2.1, but we're going to do a little bit of it. Yes, there's 15 slides left, but some of them are super fast. So I'm thinking maybe 10 minutes. 10, maybe 15 at max. Okay, so remember, qualitative or categorical data is about categories. It's usually words that or numbers we don't do math with. So this is new right here. So, uh-oh, that's not a pen, that is a highlighter. A frequency distribution, it's a way that we can organize our categorical data, and it lists the data and then it lists how frequently it occurs in our pile of data, how often it shows up. So it tells the frequency of it, how many times it occurs. So that's what a frequency distribution is. We're going to make some nice tables. We're going to make some nice graphs. Then afterwards, my daughter's going to bring me a nice cake. Every year she bakes me a cake. So when I was a kid, my aunt used to make me a cake every single year. And it was my favorite cake. And it was absolutely delicious. But the thing is the name she called it is not the name of an actual real cake out in the world. So my daughter's been trying to replicate it every year on my birthday. Last year she was kind of close. We did a lot of research after that. And so she thinks she actually nailed it this year. So I'm kind of excited. Anyway, moving on. You'll notice I go off topic so frequently. That's just me. It's just what I do. Okay. So I already kind of talked about raw data. So in your labs, I'm going to ask you to give me your raw data. So raw data is just data that has not been cooked yet. So if one of your variables is color of M&Ms in a bag, you'll pull out a red M&M, write down red. Pull out a green M&M, write down green. Just write them in the order that they come out. You haven't done anything with it. You haven't organized it. It is raw. You have not cooked it yet. So as soon as we haven't, before we've done anything with it, the data is raw. So ways that we can organize our data is with tables, graphs, or numerical summaries. And we're going to do a little bit of that here. And categorical data is so much easier than anything else. It's so easy to organize. So the next data, we're going to have a bunch of M&Ms, and we're going to create a frequency distribution of those M&Ms. So my raw data just looks like this. It is a big pile of uncooked data. You see all of these colors of M&Ms. It's kind of hard to tell how many of each one we have, so we're going to organize it. I'm going to use tick marks, which you don't have to show me the tick marks when you create it, but it's just a great way to organize it and to put it in a table. So I would not, don't write all these down. So here we go. This is a frequency table. So I listed all of the colors of M&Ms on the left, just listed them all out nice and pretty. And then I did tick marks or tally marks, whatever you want to call them. I did the tally marks to count them. And then this is my frequency. This frequency is just telling me this is how often that color showed up. I have 12 brown, 10 red, yellow, 9 red, etc., etc. This is how frequently they showed up. This is my frequency table. You don't need this right here in your frequency table. You don't need that. This was just me doing it. It's okay if you put it in there, but you don't need it. Okay, so that's all I'm telling you about frequency table, but now I'm going to tell you about relative frequency. So relative frequency, it's a nice way to compare things because if I had two different bags of M&Ms, they're going to have different numbers of M&Ms in the bag. So in order to compare them, because I want to know, hey, what percent was blue, and it's going to make it a lot easier using a percent or a proportion rather than using a percent rather than saying, oh, well, my bag had 3 blue. Well, my bag had 6 blue. So you're comparing, you really don't know which one had relatively more because maybe that their bag was twice as big. So putting them in to the relative frequency, I can compare apples to apples. So what we do is we take the frequency, so how many total we have, and then, or sorry, how many of that color we have. So for example, blue, I have 3 blue, so I would put 3 here over how many total M&Ms we have. I don't know how many total we have. 22, 31, 37, 45. So I have 45 M&Ms. So I would do 3 over 45. And then just, I could either leave it as 3/45 or I can put it in my calculator and um, get a decimal. It doesn't matter. I don't really care either way. My open math will tell you it'll go back and forth. So we can list all of the relative frequencies in a distribution chart, and it's going to look very similar to our frequency table, but it's going to have the percent or the proportion of each one, each color we have. So let me show you what that looks like. So here I took 12 divided by 45. Then I did 10 divided by 45, and I did the math for all of these so that I could get their relative frequency. So I did all of that math so that I could get their relative frequency. So I can look at this and see 13.33% of my M&Ms were orange. 6.67% of my M&Ms were blue, etc., etc. So you can see what proportion of my M&Ms were each color. And it makes it a lot easier. So if I was comparing 2 bags of M&Ms, I could see, um, is it, do I have pretty much the same proportion of each one? All right, let's jump to a bar graph. I know this is a lot, and it's just a lot of me talking. We'll get to doing more math next week. And a little bit of math on Thursday, but mostly next week is when we're really going to dive into the math. Okay, so a bar graph. So I label both my horizontal and my vertical axis. My vertical axis is generally the frequency. We'll just write frequency or relative frequency. Horizontal axis would be like color of M&Ms. It'll be you're labeling what your data is. So the rectangles are all equal width. We draw them for each category. The height will be the frequency. And I know this is just words. We're going to show examples in a minute. I'll give you a second. I'll give you a second to write things down. And if I move too fast, make sure you yell at me and say, hey, go back to that last slide. So as I said, I'm not scary. I don't think I am. Okay, I'm going to take the M&Ms. We're going to do a frequency bar graph. Then we're going to do a relative frequency bar graph. That's not anything. So here's my frequency table. Here's my lovely bar graph. So I just wrote color on the bottom. So things you need to have. You need to have this. You need to have a title. You need to have axis labels. And then this one is the variable or the categories or whatever. You need to have the categories. Sometimes it'll be a number. If you're using discrete data, you might have numbers. You need to have all of these. These are all important. When you're doing your lab, you're going to need to make sure to have that. So it's really nice because I can look at this and I can see, okay, yellow, there's 10 yellow. That's perfect. Can look at blue. You can kind of see that blue is 3. And this just organizes it nice and pretty so you can look at it and maybe get some meaning out of it or whatever. Compare the sizes of them. Notice that the bars on these bar graphs, they don't touch. They're separate from each other. This will be um, important later on. The bars are separate from each other. They're just nice and pretty in bars there. Can I move on? You guys need a moment. We're good? Okay. So now we're going to do the relative frequency. It's going to look almost identical. Almost identical. The only difference is that this right here says relative frequency instead, and these are all the proportions that we had on our graph. So that's the only difference. They look basically the same because, I mean, they're still the same data. So they look pretty much the same. All right, we're almost done. So this is probably the first and the last time you'll ever hear about a Pareto chart. I don't, they're not that important, but they're part of our standards. They're part of what I need to teach you. So the Pareto chart is only it's just to look pretty. So we only use it for categorical. And the only thing we do is we just organize it so that the bars are the tallest bar on the left, the shortest bar on the right. I'm 99% sure that they do not even talk about Pareto charts on the in my open math at all. But it is something that I'm supposed to show you. So all I did was reorganize it. So the tallest one is on the left and then the shortest one's on the right. So it's aesthetics. So only for categorical data, but it's just some people find it aesthetically pleasing. So there you go. Okay, so that is the last of the new material before I get to telling you what you need for the lab on Thursday. Or you don't necessarily have to have it done by Thursday, but the kind of data you need. Any questions on what we've learned tonight before we talk about the lab? Okay. Hopefully I can get to it. I need to get to a clean screen. There was one back here. Okay, so I am going to, on Thursday, I am going to go through the first lab and I'm going to go through it. What I do is I act pretty much as if you've never used Excel before. And I teach you step by step as if you've never used Excel before, how to do the labs that we're doing. So the data that we're going to need, you're going to need categorical data. You need 20 data values. So The lab itself, if you open the lab without watching the instructional video or without being in this class, it's going to say 50. You don't need 50. The reason I left that on there is I'm trying to reward people who actually pay attention to directions and don't just try to go rogue and figure it out on their own. So basically, by paying attention right now, you're being rewarded by only needing to collect 20 data values. Remember, categorical data is something like a color or a characteristic. I I don't recommend using your friends yet. Yes, you can if you want, but generally, the first couple of labs, the data is not that important. So if you're going to use your friends for anything, save it for the final project. What you could do for categorical if you want, you can stand in front of your closet and write down the color of 20 articles of clothing. You can stand by your bookshelf and write the author's name for 20 books. That's categorical. Or maybe the genre of 20 books. You could sit on your front porch and look at the color of 20 cars that drive by. Open up a bag of M&Ms or Skittles and and you know look at the colors of those. You can scroll through social media and look at the hair color of the first 20 friends you see. Whatever you want to do. Something, just make it simple. It doesn't have to be meaningful. Next is continuous. Once again, 20 data values. 20. So continuous is a little bit tougher, but still not terrible. You can go on the weather site for your city that you live in and look at the high temperature for the last 20 days. You could, if you like record albums or maybe even Spotify, look at a playlist and how long the tracks are for the first 20 songs. Um, what else could you do? Look at rainfall for the last 20 days. You could just, it's March Madness. You could look up some basketball players and pick 20 basketball players and look at their height. However, I recommend if you do that, convert them all to inches. Trust me. Just convert them all to inches if you do that. So things like that would be continuous. Don't make it any more difficult than it needs to be. Okay. Last is discrete. Once again, 20 data values. Um, pick up mm, 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 mm. Pick up a book that you're reading and count the pages in 20 of the chapters. That's kind of a lot, but I mean, it's something you could do. Um, look at 20 of your friends that you know and how many children they have. That's the one I did. You could, I have all sorts of ideas. For some reason, they're not in my brain. You can look at I don't even know. Um, there's plenty of things. Maybe look at playlists on Spotify. Find 20 different playlists and write down how many songs are in those playlists. So discrete data are things that are countable, things that are countable. So find something that's countable. There you go. So this is all you need. If you don't have them by Thursday, it's not a big deal. Some people just like to jump straight into it after I've done it in class because it's fresh in your brain. You don't have to have it ready, but this is what you're going to need for lab one. And the nice thing is the continuous data, you're going to get to use it for two other labs after this. Do you have a question? Okay. Any questions, comments, queries, concerns? Can type it in the chat or unmute. I don't have anything else for you unless you're typing in chat. Give you a second. Okay, so I'm all done for today. If you have questions, send me messages through Blackboard. You can send me a regular email. You can even send me messages through my Open Math. Oh, and another example for continuous data. Maybe you keep track of your exercising and you could talk about how many minutes you worked out the last 20 days. You can talk about how many ounces of water that you've drank in the last 20 days if you write that down. You can look at I use I'm one who generally uses data like I'll look at song length. I will do um I will do mine is like I did earthquake magnitudes. You can look at 20 last 20 earthquake magnitudes. Wind speeds, you that would be kind of cool actually. You can look at top wind speeds of the last 20 hurricanes that the US has done. Temperatures are always good. You can even just look at 20 different cities and choose, well, that wouldn't work as well. I would say that probably better would be like looking at the last 20 days. Even though, I mean, that could work. I don't know. What else? Continuous is the hardest one. It really is. But just try not to like make it too difficult. Maybe I mean, we don't have 20 days to do it. I was going to say keep track of your next 20 trips that you take and how much time it takes you to get there. Hmm, I don't know. That's what I got for you right now. I don't know if can you look up phone call length in your phone? If you can look at how long you've talked on the phone, your last 20 phone calls. And that could be a fun one. And just try not to make it too complicated. All right. And thank you. Thank you very much. You guys have a great night. I'm going to see you Thursday. Send me questions if you need it. Oh, I was going to really quick, my open math. There is a message instructor. If you send me a message through my open math, I will absolutely answer it, but I'm going to answer it through, I will answer it through Blackboard. Oh, my daughter's here with my cake. So I'm going to go. Bye, everyone. Have a great night. Thank you, sweetie pie. Wait 1 second.